It started out just like any other day at Prospect Mountain.
Excuse me? What up?
Except something was a little different.
Velocity is 8.5 meters per second. So you describe the energy at both points. The first point is all kinetic energy.
As students began to accumulate physics knowledge, their brains slowly began to melt. In fact, they were turning into zombies.
Energy is equal. Terminal heights of 3.68 meters. We use that 3.68 meters.
Eventually, the zombies would turn on Niels
We were given an
Boring.
additional 1.5 meters per second initial
Little did they
velocity.
know, Niels Boring knew how to skateboard.
So as you can see, you cannot simply
Let's pause for some physics. Here's a lesson on momentum. As you just saw, the zombie moved much slower, even though the same amount of force was affecting both of them.
This is because of momentum. Momentum equals mass times velocity. It has some relation to force. Net force equals the change in momentum over time. If force and time are equal, then momentum must also be equal.
Gary's mass was much larger, so his velocity was much smaller, and vice versa. Okay, let's see that scene again.
Hi, I'm Kay Sizzle.
Hi, I'm Laffy Taffy.
We are here live at the scene of a pursuit in progress.
A man by the name of Niels Boring has started an outbreak. Due to his extremely boring lectures, the students have turned into physics zombies.
The lectures are so dull, they're melting the students from inside, turning their brains to mush.
Look, here he comes now! Oh, ew, and what is that behind him?
Oh my god, it's a zombie!
Niels has entered the bowl and has started to circle around it. Only the centripetal force, which is directed inwards, will help keep him on track.
In order to calculate his centripetal acceleration, we can use the equation v squared over r. Seeing how the radius of the bowl is approximately 5 meters and his velocity appears to be 6 meters per second, Niels' acceleration comes out to be 7.2 meters per second squared.
Gravity is what prevents Niels Boring from flying out of the bowl.
Thank you for joining us with this special report.
We find our hero in quite a predicament. Niels Boring is trapped on a half-pipe, and his only way to escape is to ride down the half-pipe. Unfortunately, a zombie is waiting on the other side. Niels Boring does what he was born to do, kill zombies. Using his trusty metric saber, Niels Boring will defeat the zombie on his way to safety.
Use your trusty meter stick, Neil!
In order to cut the zombie's head off, I need to increase the velocity of the metric saber. Because angular momentum is conserved, all I have to do is bring my arms together, which decreases my rotational inertia. This will give me sufficient angular velocity to behead the zombie.
Dun dun dun!
Here we can see rotational inertia I times angular velocity omega is conserved. By decreasing I, we increase omega. This is the science behind zombie killing.
The metric saber made of the finest pine is handy for killing zombies at all times. Watch the demonstration. As you can see from our lovely demonstrator, zombies are easily slain by the metric saber. The metric saber is the most efficient way to destroy zombies. And the price is right. Call now and we'll throw in, for free, a tomato peeler, and you can pay in easy payments of $9.95 a month. Metric saber, decimate. zombies.
Breaking news from channel 384. I'm Maria Frangioni reporting on scene. We are in the middle of a live, high-speed chase. We are going now to Weston, who's our senior zombie apocalypse correspondent.
Thanks, Maria. We are here at the scene where the zombie infestation has first taken place and the heroic Neil Boring has escaped. An anonymous tip has told us that Neil Boring will be here at the half-pipe. On a side note, I have been bitten in the back of the neck by a zombie. We are all going to die.
Because energy is conserved, Niels Boring's potential energy turns into kinetic energy. In order to increase his energy, he must apply force to his skateboard, thus overcoming the effects of friction.
When skateboarders ollie, skateboarders undergo projectile motion. Initially, the vertical component of velocity is upwards, but throughout the trick, the acceleration due to gravity changes back towards the ground. At the top of the path of travel, the only velocity is from the horizontal component, which remains constant throughout.
Eric's gonna help Niels Boring get away from the zombies. He's gonna have to try to jump over this obstacle by doing an ollie.
What forces are involved in that? First of all, there's the weight of the rider pushing down on each of his feet. There's also the force of the ground pushing down on the pushing up on the skateboard. And the force of gravity pushing down on the rider and on the board.
The skater accelerates himself upward by explosively straightening his legs and raising his arms. During the jump, his rear foot exerts a much greater force on the tail of the board than his front foot does on the nose, causing the board to pivot counterclockwise above the rear wheel.
As the tail strikes the ground exerts a large upward force on the tail. The result of this upward force is that the board bounces up, begins to pivot clockwise, this time around its center of mass.
With the board now completely in the air, the skater slides his front foot forward, using the friction between his foot and the rough surface of the board to drag the board upward even higher.
The board is now level at its maximum height. With both feet touching the board, the skater and the board begin to fall together under the influence of gravity.
Gravity eventually wins out and the skater bends his legs to absorb the impact of the landing.
Now that we know the forces involved in the ollie, Derek will be able to jump over this obstacle and help Niels Boring escape from the zombies.
coordinate system. As the zombie heads down the ramp, she will be heading in the X direction. The Y direction, she's not heading in, so it will be 0.
Her mg, or weight, is going down. Her normal force is perpendicular to the surface and going up. Thus, her net force is going down the plane.
Alright guys, this is theta. Theta represents the angle at which the ramp is lying on. The bigger that angle, the better chance the zombie has to catch actually this area. But because this angle is so small, she will not have enough acceleration to catch them. Also, theta represents, if you draw a dotted line down from Fn, the perpendicular one, it represents the same angle here as it does here. The equation that is used with theta is A equals G sine theta, which is acceleration A, G 9.8 meters per second squared sine theta, which is the angle.